what I'm going to do now is actually walk you through a case study. Okay, we will read. This is a quality improvement case study. In fact, this is one of the projects that I was leading and facilitating, and so I've just built a case study around that project. We will go through the different steps of a QI project and see how various tools are applied for data collection and for decision making, etc. And hopefully that will give you a better idea if you keep this picture in mind. Okay, how this entire case study follows. You That will really help you um, to answer questions on your test. Yeah. Okay, so let's go to the case study. All right. So here's the background story. Okay, the medicine department of City General Hospital. Again, names have been changed. So City General Hospital has been experiencing unusually high discharge exit interval for patients admitted to the medical wards. Okay. So exit interval, how is it defined? It is the time it takes for patients to leave the wards once the decision to discharge has been made by the clinical team. Okay, so that is what exit interval is, and the hospital has been experiencing high discharge exit intervals. And this is an important system level measure for the hospital, and it needs to be addressed in order to improve patient flow. Okay, now the chairman of medicine department, who was entrusted by the hospital CEO and quality council to look into this matter, has sponsored an improvement team to improve discharge exit interval in the medical wards. So what you will see here is, so there is a problem in the Department of Medicine, and it was noticed by the Quality Council and by the hospital's leadership. And then what the hospital CEO and the Quality Council did is they entrusted it to the chairman of the medicine department. And what the chairman does is create an improvement team to go ahead and improve this process. Yeah. Okay, so that's what it is. So as you can see, there is a system level issue. The leadership is involved. The leadership is engaged here, and then an improvement team is created. So these are different steps of a QI project, right? So the leadership is engaged. There is a clear sponsor for the project, and an improvement team has been formed, and they know what they're working on. So these are the different steps. We have looked at this earlier, so let's quickly review them. First is you clarify your aim for the project, then you collect some baseline data, then you establish a business case about why this project is important. You form an interdisciplinary team to work on it. You understand the current process, what is happening right now, and you use certain data, your baseline data and certain tools. You establish your measures. What are you really going to measure, what are you going to track, and then you go and collect data on it, and you develop some ideas that you want to test, and then you test those ideas using a PDSA methodology, and then you map a new process about how, what would your improved process look like, and then you spread that. So you'll be testing on a small scale, but once you succeed in your testing, you'll be expanding that. And so that is your spread. So you'll go from one ward to the other, and so you'll expand it throughout the department. And then what you will do is you have to continue to monitor and sustain your gains. Okay, so these are the different steps of your project. So let's start with the first step. So what the team does is, now they create what is known as a project charter. A project charter, we've seen this before. A project charter is like a one sheet of paper, or one or two sheets of paper, 1 or 2 pages, where you outline everything about your project. So you write your problem statement. What are you really working on? You write your aim statement. What are you trying to achieve? You will write the names of your team members. You will write your project scope. You will write your business case, in short, about why this project is important. You will write down your measures. So what are your outcome measures? What are your process measures, etc. And you will document all of this. So what the team did is they defined their problem. What they found is currently only 49% of all the patients on the medical floor exit the ward within 2 hours after the care team makes the decision to discharge. So the exit interval, the acceptable exit interval is 2 hours, which means once the decision for discharge has been made, the patient should be leaving the ward within 2 hours. Okay, so that is acceptable. But currently, only 49% of the patients are meeting that criteria. Okay, and what we have also found is that the average exit interval over the past 2 months was 180 minutes, which is 3 hours. So the average across all the patients was 180 minutes. So this adversely impacts the inpatient bed capacity, causing a reduction in the number of beds available for inpatient admissions and transfers, and it increases the overall length of stay and negatively impacts patient satisfaction. So in effect, this last paragraph you see here is your business case. It tells you why you need to work on this, and you could build in some details. So what does the bed crisis look like? How much time does it take for patients to get transferred to the medical wards because there is this bottleneck? Or how much does the length of stay increase, and how much is it costing the organization? Remember, for every hour that a patient stays in the system, there is a cost involved, right? And how much does it affect your patient satisfaction? If you go out and survey your patients and ask them how much it affects them, they will be able to tell you. So that's your business case right there, right? So they have defined a clear problem, and they have told you the business case. Now, again, this is your business case. Why do you need to reduce it? Why do you need to work on this project? Because if you reduce this exit interval, it will have some positive upstream and downstream effects. What does it do? It reduces overall length of stay, it reduces the burden on existing bed capacity, and it increases patient satisfaction. Okay, these are all important system level metrics for any acute care hospital. So the team now goes about and sets a name. So remember, they came up with this problem statement to come up with this, right? 49% of all patients. How do they know all this? That means they've collected some baseline data. They've looked at their data over the past 2 months, and they probably went back and looked over 2 months and found out what the real picture is, and this is what they found. Okay. Now, based on that, they will set an aim. So what they want to do is they want to increase the percentage of patients with an exit interval of less than 2 hours to 70%. So remember, right now it is 49%. They want at least 70% of their patients to be discharged or to leave the ward within 2 hours in the next 3 months. Okay. So now what they've done is they've set a clear aim, and this is something that is measurable. Remember, smart aim, right? It has to be specific, it has to be measurable, it has to be achievable, it has to be relevant, and it should be time bound. So this is a smart aim. Okay, and the project scope is they define the boundaries of their project. So where are they going to work? They're going to work in medical ward number 3, and the time boundaries are they will be working between January and April of 2015. Okay, and then they will also list out the members of their team, so they can identify who should be on the team. So ideally, they will have people from that particular ward, their nurses, physicians on that ward, residents who are working on the ward. They'll need a quality professional in there. They'll probably have to get case managers on board as well. So they have to come up with the right kind of team that will help them to succeed in this project. Okay. Okay, now what they want to do is, okay, they have now started this project. Now they want to understand the current state. What is currently happening in our project? So what they will do is they will map out the current process. And what tools can they use to understand the current process? They can use a process map or a flow chart. So in effect, a flow chart tells them what happens from the time the patient gets admitted to the time the patient gets discharged. Okay, so they can look at that entire process of a patient's journey from admission to discharge, or they could look at a piece of that whole process. So in effect, they could look at the process from the time the discharge decision is made to the time the patient exits. So what all things need to happen from that discharge decision to actual exit. Okay, so they'll map out that process. And second thing they can do is they can do a value stream mapping. So what is a value stream mapping? We have again seen this earlier. So let's say they create a process map. Okay, now this is a sample process map, and this is from the AHRQ website, and this is for the patient discharge process. So as you can see, it starts here, patient admission orders, then everything that needs to happen in care, all that will happen. There are things that the nurse has to do, discharge advocate has to do, pharmacy has to do, and from patient admission to discharge. Now I could look at a piece of this process from the time the discharge decision is made to the time the patient gets discharged. And I could do a value stream mapping, which is I will look at the time it takes for each step of the process to happen. So I will say that yes, now step number A takes 8 minutes, step number B takes 20 minutes, step number C takes 1 hour, etc. I can assign some time value to each step in the process. Okay, and that is value stream mapping. Now I can also do a value analysis. Now what is a value analysis? I could label each of those steps as value added, value enabled, and waste. Okay, remember again, this is something we talked about in our discussion on lean. Okay, so what is a value added step? Anything that is value add from a patient's perspective. Anything that the patient perceives as important, that is value added. Anything that is essential for our process, for example, clinical documenting, but not necessarily seen as value add by the patient, is called a value enabled step. And anything that doesn't fit into both of these is called a waste. Okay, so patient waiting, unnecessary, remember that acronym of downtime, right? Any defect, overproduction, waiting, non-utilized resources, transportation, inventory, unnecessary motion of people and equipment, and extra processing, right? So these are all your waste steps. So any step in the process that is a waste, you have to identify that. So I can do a value analysis, and I can see how many steps, how many things that we do between this discharge decision and exit of the patient really adds value to the patient. How much of it is simple waste? Okay, so I can do a value analysis. Okay, so that is my process map. Now the second step I want to do is, now okay, and now I understand my current process, I understand how the process flows. Now what is my problem? That the patient does not leave the ward within 2 hours. Now what could be the reasons? What could all the possible reasons that is leading to this discharge, this delayed discharge exit interval or prolonged discharge exit interval? Now, what could I do? The tools that I will use brainstorming. So my team will get together and we will brainstorm. We will think of all the possible reasons. Okay, everybody, without judging, we are all going to write down on post-it notes. We're going to write down all the possible reasons that we can think of. Okay, so we'll collect a bunch of ideas, and then what we will do is we could use an affinity diagram. What does the affinity diagram do? It helps you when you have, let's say, as a team we all come up with 100 different reasons. Okay, uh, now what we want to do is we want to put these different reasons into groups. Okay, so similar sounding reasons should all go into different affinity groups. Okay, I will group them all together, and once I've done that, then I will build it into a fishbone diagram. Okay, our cause and effect diagram, or our Ishikawa diagram. Okay, this is what it would look like. So my Ishikawa diagram has four different themes. There are people related reasons, there are procedure related reasons, there are policies, and there are equipment related reasons. And I mean, this is just a sample of a few reasons that we come up with as a team. And then you will group them. I mean, you would first have grouped them in an affinity diagram, then you simply put them into a fishbone diagram. Okay, so I have brainstormed, and then I have put the results of my brainstorming into a fishbone diagram. Now what I will do is I will look at my fishbone diagram, and what I will do is I'll look at my fishbone diagram and see, okay, now I have a bunch of reasons here. Which ones do I think, or does my team think, are the most important reasons? So now what we want to do is, out of this bunch of reasons that we have, we want to narrow down on a few that we can work with. Okay, so now we want to narrow down our list to the top 5 to 10 reasons. And what would we use here? We'll use a multi-voting technique or a nominal group technique. Okay. Now, what would I do for a multi-voting technique? I would probably ask my team. I would, put this all into a sheet of paper, and ask my people or ask my team members to rank order them. Okay, so everybody will say which ones they think are the most important. So let's say I have 10 reasons. I would ask them to rank order them in the order of priority that they think. And what I would do is I would collect all the responses, and I would see which ones have gotten the most number of votes. Okay, and which ones have got the least number of votes, and I can prioritize my options accordingly. And I could also use a nominal group technique here. Now, because remember, if I'm doing this in a group which has physicians and nurses and case managers, it is quite possible that the physicians will say that the delay happens because nurses are not doing their job. The nurses could say it is happening because physicians are not doing their job. And both of them could then in turn point fingers at the case manager, right? So this could easily escalate into a battle. If you want to prevent that, you can use a nominal group technique where you ask everybody to do this voting process in silence. Okay, you could also, I mean, multi-voting usually takes place as, there is as a vocal exercise. So you have a facilitator standing up on a flip chart, and he's going to call out each reason and say, okay, who thinks this is most important, and people raise their hand and they give their opinion, and that sort of consensus process can happen. If you don't want that, you can do this as a silent process, so that's where you will do it as a nominal group technique. Okay. All right. So now what we have done is we have understood our current process. We have found out, we've narrowed down to a bunch of reasons that we think is causing this. We've also prioritized our list of reasons. Now, so far, we've been working on the basis of hunch, right? On the basis of our hunches. Okay. Now, what we want to do is now we want to go out and collect some baseline data. We want to find out the truth, and truth will come only from the data. So we want to collect baseline data to look at how our current process is happening. And what would you do? You have to develop a data collection tool. So this is where the expertise of a quality professional will come into play, because they will tell you how to develop a data collection tool, what is the best tool to develop. And what you do is you develop a data collection tool, and you have to pilot test it. You have to test it on a small scale, meaning you have to really implement it in a real setting and see if that data collection tool is worthy or not, if it really works or not. You will test it on a small scale, probably in a small single ward, on one patient, on one single shift, etc. Come back as a team, and have a discussion. What works, what did not work, is the tool good enough, do we need to include something more, do we need to omit something, etc. So a data collection tool is also not a final exercise, right? I mean, you have to develop a rough draft, test it out, see what works or not, and then you have to come and modify it as required. Okay, one of the most important mistakes people make with data collection tool is, they develop an elaborate data collection tool that captures everything under the sun, and they will just give it to everybody on the team and say go and collect data. And people go out, collect data for weeks or months, and then they will come back. And when you look at the data, you will see that people have been collecting, I mean, what Michelle is collecting would be very different from what Leslie is collecting, would be very different from what Renee is collecting, etc. And you don't want to make that mistake. And the way to avoid that mistake is to develop it on a small scale and test it before you actually implement it. Okay. Now, this is an actual data collection tool that we used in the project. So it's a simple data collection tool. As you can see, it's a Word document. So it tells you the week when that data was collected, and which team. So in the hospital that I was working with, they have different clinical teams which comprises the consultants, the specialists, fellows, residents, interns, etc. So, and they are given, there are 10 such teams. So we identify which team we are talking about, and then you have the number for the patient. So this could be the patient identifier number, the date of admission of the patient, the expected discharge date, actual discharge date, then the discharge decision time. So when did the clinical team make the decision to discharge? You know that time. And then you look at the actual exit time. So when did the patient actually leave the ward? What day of the week was it? And in fact, we added one more column on the right, which said if there was a delay, If it exceeded 2 hours, what was the reason for the delay? Was it because a medication order is pending? Was it because the discharge paperwork that the physicians are supposed to complete is pending? Was it because the nurses did not send the order out on time? Was it because there was no patient relative available to take the patient home? Was it because the pharmacy did not send the medication on time, etc.? So the people who are collecting this data can, if there is a delay of more than 2 hours, they can mention the reason why the delay happened. Okay. All right. Now, what we did is we did this exercise for, let's say, 2 weeks or 3 weeks or 4 weeks, whatever it is. We come back and we look at that data. And what we found is that whenever there was a delay, right, the reason was mentioned to it. So if the patient was, now what we found is patient waiting for transfer to rehab was the main reason for delay. Okay, then vaccine prescription delay was the next one. Then you had medication delay, then you had waiting for family, equipment delay, company delay. Company delay means, there are lots of workers and laborers who in this part of the world, if they have to be taken back to their accommodations, then the sponsor, there is a sponsorship system here, so the sponsor has to come and take the patient back. And then that, it's a legal process here. So that could be the relay. If the patient was to be escorted to another facility abroad, then that could have caused delay. So you have all these different reasons of delay, which was noted. Just pencil it in on the data collection sheet. Now, what would you do with this data? You would build what is called a Pareto chart with this data. So in effect, what you're doing is you have identified the frequency of occurrence of each of these reasons, and you've plotted them according to their decreasing order of frequency, and you've calculated the cumulative frequency, you have calculated the cumulative percentage for each of these reasons. So go slowly here with me. Okay, on your data collection tool, you can identify the reason for the delay. Okay, and now what you can do is you can build a Pareto chart using that. Now, what do you do? Now I have the frequency for each of these reasons. Okay, so on the chart, as you can see, now waiting for transfer, there are 18 cases, 18 times this was identified as a reason for delay. Vaccine prescription delay, it was identified 3 times as a reason. Medication pharmacy was identified uh, 3 times as a reason. So I'm looking at this chart, okay, on this Pareto chart. And then what I do is I calculate what's called a cumulative percentage for each of these. So how do I calculate a cumulative percentage? I will add up the frequency of all these reasons. So 18 plus 3 plus 3 plus 3 plus 2 plus 2 plus 1 plus 1 plus 1. Okay. So that is the total number of reasons I have. Now, out of the total number of reasons, waiting for transfer made up 53%. Okay. So what is my total number of reasons? 18 plus 9, that is 27. 27 plus 4 is 31, 32, 33, 34. So there were 34 times reasons were identified. Out of those 34 times, waiting for transfer accounted for 18 times, which is 53%. Okay. Now, waiting for transfer plus vaccine prescription delay makes up 62%, accounts for 62% of the delay. Okay. Now, waiting for transfer, vaccine prescription plus medication delay accounts for 71% of the delay. Okay, so what I'm doing is I'm adding up. It is cumulative. Okay, and I can see that the first four reasons: waiting for transfer, vaccine prescription, medication delay, and waiting for family, all this accounts for about 79% of the delay. So these are the four main reasons that is causing up my delay. Okay. Now, Pareto principle tells you what? It's the 80-20 principle. So it tells you that 20% of the causes account for 80% of the results. So in this case, it would mean that 20% of the reasons would account for 80% of my delay. Now, what I'm seeing here is it's not exactly 20%, but it's four reasons. 4 out of 9 reasons. So about 40% of my reasons account for 80% of my delay. Now what this graph really tells me is, if I want to address this problem, where will I get the maximum bang for my buck? Okay, which means if I solve the problem of waiting for transfer, that is immediately going to improve my results by at least 53%. All right. So that is why a Pareto chart is helpful, because it pictorially helps you to see what is going to give you the maximum bang for your buck. Okay, where should you prioritize your effort? Okay, so now Audrey has a question. Why is this chart being used opposed to others? Um, okay, Audrey, so here's the thing. Now, once you have done your fishbone and all, right? Now you want to know, what did you do with your fishbone? You came up with a bunch of reasons. You came up with 100 different reasons why this is happening. Now, can you work on all 100 reasons at the same time? You cannot. Okay, because people are busy. You don't have enough time. You don't have enough resources. So because you cannot work on all the reasons, you have to prioritize. Where are you going to work? So for that, we first, what did we do? We came up with a list of 5 or 10 reasons those delays can occur, right? We narrowed down our list to 5 to 10. Now what we want to do is, out of these 5 to 10, where should we really focus our efforts? And to answer that question, you need to have real data. So we went out and collected the reasons. So Pareto tells you, out of all the causes that you've identified in your fishbone, where should you focus your efforts? Okay, that is the utility of a Pareto chart. So Pareto really helps you to prioritize your efforts to in an efficient way. How do you prioritize where you should be working? Narrow down your focus. Okay, that is why Pareto is helpful. Okay. All right. Now what I've done is, okay. Now I know that I have to use. Now I know that the main reason for all the delays is that patients are waiting to be transferred to a rehab facility. So I know that if I address that one problem, I will make a large amount of improvement, because 53% of my delays are happening because of that. And now what I will do is, I'll start designing my run chart. Okay. So this is what my baseline run chart looks at. So remember what our measure was. What did we find? That 49% of the patients, only 49% of patients were meeting uh, our stipulated criteria of less than 2 hours of discharge exit. We want to increase it to 70%. So in this chart, you can see that the goal has been identified as, it's in the green line. It's been identified as 75, 70%. Our baseline is the orange line, which is 49%, about 50%, 49 to 50%. Okay. Now I'm going to look at my data from week to week. So this week, what percentage of my patients exited within 2 hours? So what I find is, this week it is around roughly 31%. In week two, it is about 50, let's say 53%. Week three, it was again around 53%. Week four, it was 50. Week five, it is reduced. It is now 21%. Week six, it is about a little more than 30%, etc. So this is what I'm doing with my run chart. On my run chart, on the x-axis, I have my time variable. Okay, so weeks, week one, week two, week three, etc. On the y-axis, I have the percentage, whatever I'm tracking. And for every week, I'm going to plot my data. It really tells you how your data is behaving on a weekly basis, on a time series. Okay, so this is my run chart. Okay, so Leslie has a question about prioritization matrix. Um, so Leslie, okay, to answer that, I will be talking about prioritization matrix in a while. So let's address that question when we get to that. Okay. Okay. So now you see how we are using the run chart, right? On the x-axis, you usually have a time variable. Now another way of building the run chart is this. Now what I have done here is, in the earlier run chart, we were looking at percentage of patients who were exiting less than 2 hours, okay, on a weekly basis. Here what I'm doing is, I'm looking at individual patient exit times. So every week I'm going to choose three patients, and I'm going to look at those three patients' exit times. Okay, and every week I do that, and for a bunch of patients I've done this here for around 80 patients. You can see there are 80 patients. So patient 1, patient 2, patient 3, patient 4, right up to patient number 79 here, and I have their individual exit time. So patient 1 exited in a little less than, in about 1 hour. Patient 2 exited in I want to say around 6 hours and 45 minutes. Then patient 3 exited in about 2 hours, patient 4 in about 4 hours, and so on. Okay, so this is another way. Okay, so Audrey's question is, why not a control chart? Perfectly valid question, Audrey. You could actually convert this into a control chart as well. Okay, but the thing here is, when you begin any quality improvement project, you will start with a run chart. The reason is, a control chart, remember, is more statistically rigorous. Okay, so for that to happen, okay, so sorry to break you there, Michelle. Yes, I will be sending these slides. Definitely, I'll be sending you these slides. Okay, so so what you do is, let's say now we have started our project. We start by building a run chart, and we will build a run chart for quite some time. And after we have, I want to say, we should have a fair number of data before we can go on to develop a control chart, because control charts need control limits. And to calculate the control limits, you need to have a minimum number of data. Now, there are different rules for that, but you don't need to know that, because that's all complicated stuff. And I don't want to overwhelm you with all that information. But just remember this, that um, you will need about 25 to 30 data points at least to start building a control chart. You can, I mean, this run chart right here, it can be controlled, it can be converted into a control chart for sure. Okay. Now, while we are at this, I just want to quickly tell you something. Now, if you remember that first video, there were some rules of run charts, right? If you have 6 data points going in a particular direction, if you have 5 points on the same side of the median, if you have one astronomical data point, etc. These are all signs of non-random variation. Okay. So if you look at this chart, you will not you'll see. Okay, if you come to the far right side, you'll see 1 2 3 4. Yeah, you don't yeah, here between patient number 49 to 56, you will see there is a clustering of points, about a few patients here. So this is how you interpret if there is any non-random variation on it or not. But I don't want to get into that now. You can review our earlier video. If I send it to you, you can look at the emails that I've sent you. In one of the emails, I've sent you the link to it as well. So um, you will be able to review that for those run chart rules. Okay, so now what we have done is we have created our run chart, which will help us to track our progress. Now, another tool that I can use to understand variation in my data is what's called a histogram. Okay, now this particular histogram you see here, it is not related. No, sorry. Yeah, actually, it is related to our data. Okay, so this is, again, this is not my actual histogram, but I've just created it for our discussion here. So what I've done is, I want to see how many patients. Now I know that my patients have to get discharged within 2 hours. Okay, and I know that only 49% of my patients are getting discharged within 2 hours. But that is not that. That's only half the information. I want to see. Uh, I mean, what is the variation? What is the variation in how the discharge exit times of these patients is distributed? So I want to see the distribution. So what I will do is I will create a histogram, okay, also known as a frequency plot. So the first step for me is to divide the different exit times into buckets. So I've divided them into buckets of 0 to 30, 31 to 60, 61 to 90, 91 to 120, etc. Okay, so these are the actual exit intervals of the patients in minutes. Now what I'll do is I'll go back and look at my data and see, okay, how many patients are getting discharged within half an hour. Okay, that is within 30 minutes. They will fall into the first bucket, 0 to 30. Okay, then I'm going to look at how many patients are getting discharged between half an hour and 1 hour. and they will fall into my second bucket. And then between 1 hour and 1.5 hours, that would be my third bucket, and so on and so forth. Okay. Now, my goal here is to discharge them in less than 120 minutes. Okay. Now this tells me I can draw a line at this 91 to 120 bar. I can draw a line there. And on the left side of it are the patients who meet my criteria. And on the right side are the patients who do not meet my criteria. Okay. So this tells me how my data is distributed. Okay. So that's how a histogram is used. So histogram helps you understand how the data, the spread of the data, what is your center of the data. So we know the center of our data is 91 to 120. It also tells you the amount of variation, if there is any skew, etc. Okay. All right. And this is again, this is how for developing a histogram, this is what I do. I first create bins, and then I put the frequency. So I have different frequencies here. So between 0 and half an hour, I have 26 patients. Between 31 and 60, I have 35 patients, etc. And I have a few patients who took an inordinately long amount of time to exit the hospital. So you can see 390 minutes to 420 minutes, which is about 7 hours. Okay, so there were five patients who fell into that bin, etc. So that's how I do my histogram. Okay, now what I want to do is I want to look at a correlation. Okay, I have a theory. I have a theory that if the physicians write their discharge orders before 10 a.m. in the morning, okay, if they write their discharge orders before 10 a.m. in the morning, then patients will be able to exit within 2 hours. Okay. And the reason I have that hunch is, once the physicians write the order before 10 a.m., that gives enough time for the nurses to process that order. That gives enough time for the pharmacy to process their medication orders. That gives enough time for the patient relatives to get prepared, etc. So that is my hunch. So what I want to do is, I want to look, if you can look at this table that I have here, I have time, that's TTO in minutes, which is time to order the discharge. Okay, time to order the discharge. So I'm going to calculate that time from 8 a.m. in the morning. Okay, so 8 a.m. in the morning, why? Because that's when the physicians begin their daily rounds, their clinical rounds. Okay, so let's say they for patient A, the physicians wrote the order at 9:30 in the morning. Okay, so what would be my TTO? It's 8 to 9:30. It's 1.5 hours, which is 90 minutes. Got it? So that is the TTO in minutes. So I'm going to calculate the time it takes them to write the order, calculated from 8 a.m. in the morning. If they write their order at 11 a.m. in the morning, that's 8 a.m. to 11 a.m. That is 3 hours, which is 180 minutes. Okay, so that's my time to order. And EI is the exit interval. So exit interval is again calculated as the time the order was written to the time the patient actually exited, and that's in minutes. Now what I've done is I have two continuous variables here, right? It's time. So minutes could go from 0 up to infinity. Exit interval can also go from 0 up to infinity. So I have a continuous variable, two continuous variables, and I'm going to plot them on my scatter plot. Now on my scatter plot, my dependent variable goes on the y-axis. So here my dependent variable is exit interval. In other words, I'm saying that time to discharge order somehow affects my exit interval. So the effect is on the exit interval. So my exit interval is the dependent variable. So that goes on my y-axis. And my independent variable is time to discharge order in minutes. Okay, so that's on my x-axis. And what I'm going to do is I'm going to plot these. So for patient number one, time to order was 150 minutes and time to exit was 210 minutes. So I'm going to find the correlating point here, the corresponding point on this graph, and I'm going to plot it as a blue dot. And I'm going to do that for every patient on my list here. And that will give me my scatter plot. And if you do it on a statistical software, what it does is it will plot all the points for you, and it will also give you what's known as a trend line. Okay. Now here, surprisingly, what you see is that there is a, what kind of correlation do you see here? There is a negative correlation. Okay, there is a weakly negative correlation. There's a weak negative correlation. because the line is sloping downwards. So what my data is telling me is that if the discharge time to order the discharge is less, the exit interval is more. So this goes against my theory. My theory was that if the order time increases, the exit time will also increase. If the order time decreases, the exit time will also decrease. But my data is telling me something otherwise. Got it? Now, now let's not get into the reasons of why this is, because it's a completely unique thing to this healthcare setting that I have here. So that's not for our discussion here. But I just want you to understand how scatter plots are developed and how they are used. Okay, scatter plots tell you the correlation between two variables. Now, correlation is not the same as causation. Okay, I am not saying that time to discharge order will cause a better exit interval. I'm saying that there could be a correlation between the two. It's the same as saying this, okay? Now, there is a correlation between sale of ice creams and the number of shark attacks. Okay, sale of ice creams and shark attacks. Now, that is a correlation. It's not a causation, meaning, sale of ice creams is not causing increased shark attacks, right? Why would that be? That sounds absurd. But the reason they are correlated, because why? When does the sale of ice creams go up? In the summer season. Summer is also the time when people go for a swim in the ocean, and that increases the number of shark attacks, right? So that is correlation. Again, the cause of, I mean, the incidence of hypothyroidism goes up as the altitude increases. Okay, this is found in the Himalayan regions. Now, why is that? Does high altitude cause hypothyroidism? No. The reason is the amount of iodine depends on the kind of salt you're using. So if you're using, sea salt, you get your iodine. But as you go higher up the altitude, the iodine content in the water is very low, and that leads to hypothyroidism. So you understand that is what correlation means. Okay, it just tells you that. One factor could have an influence on the other factor, or that just that they are sort of positively correlated or negatively correlated. So if the dependent variable increases with increase in the independent variable, that means there is a positive correlation. If it decreases, that means there is a negative correlation. And if you don't see any such pattern, there is no correlation. So Audrey says, please re-clarify, why does ice cream correlate with shark attacks? They are not related factors. Exactly, they are not related. That is why they are not causing each other. They both are related to a common event. What is that event? It is summer or the season, right? So ice cream sales will go down in the winter, and in the winter, people taking a dip in the ocean will also go down. So that is why shark attacks will also go down. Okay. So I mean, don't hang up on that example actually, because I mean, I'm just trying to make you understand that it's not causation, it is correlation. Okay, so I could look at the sale of ice cream cones and the number of shark attacks, and I could create a scatter plot, and I will see a positive correlation. Okay, and once I see that positive correlation, I can go back and see, analyze why that happens. And the reason I come up with is that it's because it depends on the seasons, right? Okay, so that's for scatter plot. So remember the word correlation for scatter plot. Okay. Okay, now what will the team do? The next steps for them will be the team will brainstorm. Now they understand the reasons. Okay, they have looked at their Pareto chart. They know that the biggest reason is time it takes for patients to go into rehab, and also from the scatter plot they have found that time to discharge order does not really help you to speed up your process. So there's no point banging your head against that process. Trying to convince physicians to write the order quickly, that is not going to help a lot. So they've now what they will do is they will come up with some possible solutions based on their understanding of the extent of the problem and the most frequent causes. So now they could probably try to find some solutions for speeding up transfers to rehab, for trying to speeding up medication orders, trying to speed up families reaching the patients on time, etc. At this point, Leslie, going back to your question, they could use a prioritization matrix. They can use a prioritization matrix. So let's say now they come up with let's say they come up with 8 different solutions. Okay, for let's say for tackling the transfer to rehab process, they come up with 8 different solutions. Now, out of these 8 different solutions, which one should they work on? What will that depend on? That will depend on the ease of implementing the solution and the impact of the solution. That will depend on the resources the solution will require. That will depend on the support they can expect from all the key players in their system, etc. Okay, so the success of their solutions will depend on a bunch of factors. Now, based on these different factors, they could create a prioritization matrix and they could map out which solutions will be easy to implement and will have high impact, will be difficult to implement, will have low impact, etc. Okay, so prioritization matrix is something you use as a decision making tool for QI implementation. Okay. Now, here you don't have any data to back it up. You only have some hunches. That is why you should not use them in the earlier process. In the earlier process, you want to rely on hardcore data. That is why you use a Pareto chart and a fishbone diagram. Okay. Here you only have a few hunches. Okay. So you will use a prioritization matrix to prioritize your solutions. Once they have prioritized their solutions, they would now create a plan, and then they would carry out their PDSA cycles. They'll plan their test, they will carry out their test, then they will analyze how well the test went and what they learned through the test, and then they will decide their further course of action. Okay. And what tools can they use? They can use a Gantt chart. Gantt chart is basically a simple project management tool which tells you who will do what and by when, and what is the sequence in which these steps need to happen, etc. And a deployment chart, what does a deployment chart do? Deployment chart tells you what is Audrey going to do, what is Michelle going to do, what is Leslie going to do, what is Renee going to do, what is Sajid going to do, etc. Okay, a deployment chart tells you which task is owned by which person. Okay, so these are good project management tools to be used in the implementation part. And as an intervention, they can design a new process. Okay, if they know that there are a lot of wastes in their previous process, in their baseline process, if they know that there are a lot of um, what do you call them, there are less value added steps in their previous process, they can probably design a new process. Okay, so I want you to do this. I want you to keep this example in your mind, and because with examples are powerful to understand, because it's a nice thread that helps you to connect these various tools together. It gives you a nice sequence. And remember this example whenever you get some questions on your exam as well. Okay.